My name is Jerry Melnick. I head up this SIOS operations in the US. How many of you have ever heard of SIOS before that have come here? Okay, well, it's actually a smaller group than I thought. Well, there's a few back there that are holding back on me. So SIOS actually has been around for about 20 years. One of the first to do a Linux implementation for high availability clusters. And we have a parent corporation in Japan. I often tell people we are big in Japan. In fact, we are quite large in Japan. They got started early on Linux high availability clustering back in, I'd say, about 2000, and took it quite strongly in that market. The rest of the world, I have joined the company about 6 years ago, and actually, this marks my 6-year anniversary as of this week. And I thought, what we're going to do in this session is first kind of go to a high level with availability, talk a little bit more about that. I'll give you some color on why I think that might be worth the conversation. Maybe some of you all know way more than I realize about availability. We're going to go do it anyway. And then Michael will give you a little deeper dive on the technology and whatnot. From my background, actually, I've been in the availability space for about 20 years in database systems prior to that. In my previous gig, I was CTO at a small company that did fault-tolerant computing for, with software, which had previously been done in mainframe computing. And so that's the very highest end of availability. And I saw a lot of things. When we sold that company off, and I saw SIOS, and one of the things I found out pretty quickly, or thought pretty quickly, that what SIOS was doing was covering a lot of space that we could not cover because of technology reasons in the fault-tolerant computing space. So it had a much broader application to problems that people wanted to solve. And one of the things SIOS brought to the table that I really found compelling was its ability to be able to operate on many different environments, including operating systems, platforms, and actually moving to the cloud 3 or 4 years ago was really a matter of just a few weeks worth of work for our engineers. So we've been doing this for a long time. We have a lot of experience. HA is all we think about. It's our sort of bread and butter, so to speak. In the US, we've been building the company rapidly over the last 3 years in terms of use cases around helping companies move their enterprise applications to the cloud, one of which is SAP, which has become an important focus for us. And that we're going to talk a little bit about right now. So just to get right into it, what we saw happening I'd say about 3 years ago, and in fact it was probably 3 or 4 years ago, the first use case we saw SQL Server a small SQL Server application moving into AWS. And it was a healthcare application, and I called up all my friends who all understand high availability and applications, and I said, so you really think people are going to put the absolutely most important applications, the one that keep them up at night, into a public cloud, really? And most of them said, no, that's not happening. And sure enough, within about a year, that whole chemistry had changed, and we were starting to see this new data center, which we were going from on-premises, traditional data centers, into a new data center, which really you can't characterize as just one way of implementing a enterprise system, but many, physical, virtual, and cloud. And that was posing all kinds of new problems for people who were really concerned about how am I going to keep those applications up and running and manage all that stuff so my business can manage their business. So the new data center really became something that was perfect for us. It's like, time was reborn again for us to be able to play, because this is the space that we play in. It's these very large variety of different types of computing environments that people need help keeping their applications running. And that evolution now represents more than 80% of our business. So in short 3 years, the evolution into cloud represents almost I would say 80% of the new customers that we see, just to give you an idea how fast this has moved. And these are typically enterprise class customers, people who have large data centers and have important applications, not just sort of a sidebar in their work. So I think that always surprises people. I call us sort of the litmus test of the industry, because it's very hard when you sit in any particular seat to understand how big the elephant is or what it looks like. Everybody sees like one toe or the other. But we get to see across all of these and see what people are asking for. So we get a sense of sort of where the industry is moving and what's happening in it. And it's a very exciting time, although still, my perception is relatively early in the big scheme of things, given how much IT infrastructure exists outside of cloud right now. So let's just back up for a second. And SLA, how many of you are familiar with the term SLA? Service level agreement, yeah. I once asked, SLA is an important term because it imparts so many different things to so many different people. I once asked an IT guy at ESPN when we were visiting them, so what's your service level agreement? You know, how long can you tolerate downtime? And he looked at me, and we were running the little sticker that was going across the bottom of the screen, you know, announcing results and whatnot. And if that went down, the sticker went down, and people turned off their TV, obviously. So he told me, he said, my SLA is it needs to be back up before my VP can pick up the phone and call me. So it was really about him, not the business. And that's actually an interesting observation that I've had now a couple of times about availability of a system. Everybody, we used to have these charts. They would talk about if you're down for 2 minutes, you know, it's going to cost you this $1 billion. If you're down for 5 minutes, you know, the business guys get excited, but it's kind of hard to everybody think about it that way. But what we found was it was very personal. And the person it was personal to was the IT guy, because his job was on the line if that system went down. And we were sitting around the table once with, I think it was in Switzerland for a pharma company. And we were talking about fault tolerance computing and why it was important and availability and why it was important. IT guy sitting in the corner. He was kind of like down there. You could tell he looked pretty tired. And I said to him, and when finally I said in the conversation, and the reason why this stuff is important to you is because you don't have to come in on the weekend and fix it. And he looks up from us and he goes, I really don't want to come in on the weekend. And then I understood that's what availability was for. It was important to keep that guy happy because he was going to lose his job and he was going to lose his mind if he had these kinds of systems that are so critical to the business. And that's what an SLA is. That's really the promise. The interesting thing in the cloud environment is you'll read things about SLAs all the time. You know, you'll say this region has an SLA of 4 nines, and we'll talk about 4 nines. You know, only 5 minutes of downtime, or only less than an hour of downtime all year. Well, that is the composite of all, typically, for the cloud providers, that is a composite of all the zones within there. So that means that you could be in one zone and you can't necessarily get those kinds of guarantees. So you actually do need other techniques to be able to get those kind of guarantees in redundancy. And we'll talk about redundancy as well. So what is availability solutions? What are availability solutions? Availability solutions are really an insurance policy, more than anything else. You have to have redundancy. You have to have some type of insurance that if something happens, you're taken care of. And in the case of systems, you're looking at solutions which can get you up and running as fast as possible, potentially. Maybe that's not so important. But you're going to buy the amount of insurance that you need for the problem that you are concerned about avoiding. And like all insurance policies, it ain't so simple, and availability ain't so simple. It's actually quite complex. And the fine print is extremely important because what's covered in an insurance policy may or may not be what you really are going to get hit by. It may not be the lightning strike you thought, or it may not be the flooded basement. And there may be contingencies around. So you have to have coverage in ways that you haven't really perhaps understood or known. And like the farmer's insurance ad, and people will laugh as, you know, one of the values that SIOS, quite frankly, brings to the table is we know about a few things because we've seen a few things. And that's what it's all about, is that you can't really anticipate it. So you really have to understand what that fine print delivers to you, because when the problem occurs, and you spend so much money and time to make sure that you're going to avoid that problem, when that problem occurs, you better make sure that you're covered for it. And just like that insurance policy, that's what systems have to do. I have a perfect example in another system, which some people may relate to, is I had a flooded basement about 3 months ago, which took out a good amount of material down there. And I've lived in this house for 20 years, and I have one pump, as it turns out, one sump pump. And the pump didn't fail, but what happened was something fell in the well and fell on top of the paddle and kept it from filling up and pumping out. It just thought it was always full. So I said, I need redundancy. I need 2 pumps or something. And then I started reading up on it, and I realized that, oh, well, this wasn't just about putting another pump in. you know, I could put another pump in, but there's these backflow valves. And if the backflow valve breaks too, then the pump better have a second backflow valve. If it has a second backflow valve, well, you know, I live in Massachusetts. It gets pretty cold there at night, and things freeze on the outside. So when you're pumping outside, that backflow valve may not make a difference, but maybe it freezes the pipe. So it turns out you really need multiple pipes going out there. So the way you think about redundancy on a system has to look at all the use cases and all the types of failure cases and how you build it, and that's the insurance policy. So the goals of any kind of availability system is to keep the business up and running and minimize downtime, eliminate any kind of data loss, and maintain data integrity. So when you get back to computers, that's what it's all about. That's redundancy in system, unlike redundancy in my sump pump. The goal was to keep the water out of my basement, which didn't work too well. But redundancy is the foundation of that. How you manage redundancy, how you manage recovery, and how you get the system, how you detect a failure and recover are what it's all about. And that's how you put the system. And this is what we think about at SIOS. We've thought about it for 20 years now. We've seen a lot of these failures, and we've had to build in a lot of safeguards in order to do that. So the techniques that you can do it is you can build HA into the application. And if you look at some of the web scale type applications, Netflix is a perfect example that people have talked about for the last 7 or 8 years, maybe 10 years. They've built web scale type availability by building redundancy into the application and detection of error detection. And they have an amazing staff of people to do that. And they've spent a lot of money, and they have to take care of a pile of stuff, and they can do that. Most of the rest of us mere mortals in business want to rely on a redundancy guarantee and a recovery guarantee that's at the infrastructure level. And there's many ways to do that. People cover data, they cover networks, they cover applications. If you had to build it all into the application, it would cost you immensely. So where our focus has been, and where we see the importance, particularly in database applications, have been around covering recovery, error detection in the tier at the infrastructure level. So the application doesn't need to know about what's happened in terms of any of the aspects of resource loss, but in fact, the system underneath it transparently detects it and recovers it in time that the VP doesn't pick up the phone. And that's really the technique that we've looked at are all about transparent application recovery and transparent data replication and protection. Okay. So achieving availability actually at the very high level is straightforward. We're losing this thing. There we go. First part is detection. And the scope of detection is important. So what am I detecting? I'm detecting some kind of failure that's occurring, that's impacting operations of the application. It could be at the application tier. It could be at the network tier. It could be at the storage tier. It could be at the infrastructure tier. It could be within the OS. So where you put your probes and how you try to find out what's happening and figure out how to manage that is really important. So detection, and that's again the fine print. What do you cover? And then recovery. So now I've detected a failure. Well, say it's in the application level. You know, I want to take the path to least resistance or risk when I recover from a problem. So if it's in the application, you know, I might just try to restart the application. Maybe it's just a service in the application. Maybe I just need a probe in the service. So rather than getting crazy and taking everything down and moving it someplace else, I just recover that service. Or maybe it's a network, and I can retry the network or the storage device, and I can do it a certain number of times. So you put protocols in place to do a reasonable recovery that is not going to impact your operations or risk the operations. There's a lot of risk whenever you do any kind of recovery. There we go. And then you continue operations. Now, in the case of high availability and clustering, we'll talk about, you know, your job is really to get that thing up and going as fast as possible. So that whole detection, recovery, continue is a recovery, what we call a recovery time objective, or RTO. And that's the amount of time it took you to get from the time that you detected an error that was impacting operations to the time that you recovered and are running again. So when people talk about availability, they typically, and SLAs, they typically talk about RTOs. How fast does this have to recover? Again, you know, for the guy at ESPN, it was like before my VP gives me a call. But others, you know, you could use a backup recovery technique if it doesn't have to be up for a week, not a problem. In high availability systems, it is a problem. I mean, you'll never get it back up in a week, in time, if you have a very short RTO. So you have to come up with schemes to be able to recover very quickly and accurately. And that's the other case that needs to be discussed, is accuracy. And part of when you build availability systems, accuracy and reliability are a big deal. Unreliable availability system is basically useless. So putting it all together in the right way to make sure that you can recover and get operating in the RTO specified by the SLA is a key piece. And that entails a lot of thought about, you know, how can you ensure recovery. So it's not just you know, ensuring operations, it's ensuring recovery into a state that can continue operations without losing data in the time frame. We'll talk a little bit more about that too, the time frame that you're supposed to do it.
That remote hates you.
It does hate me. There you go. So we talked about RTO. RPO is recovery point objective, and again, that's on a data level. So the second thing is, so how much data can I afford to lose in a loss situation? And you know, in a case of high availability and fault tolerance systems, 0. I can't afford to lose any. You know, any data loss will be a transaction, could be a financial transaction, some other kind of catastrophic. It's going to cost me big money or big jobs. In other cases, you know, I can afford to lose 5, 10, 15 minutes. I can afford to lose a week's worth of days worth of data. I can go back to, it all depends on the application. It's all dependent on your environment. I think so the nines, let's just talk about the nines for a second. You all hear about nines. Marketing people have used nines for years to confuse everyone. And you know, in the world of availability systems, nines have a very specific meaning, and that really is about the promise for the SLA and how much downtime you will incur at any point in time and over the course of a year. And so we'll characterize that, but high availability systems, true high availability systems are designed to deliver 4 nines of availability, which is basically about 60 minutes of total downtime in a year, and no loss of data. Yeah, I'm losing. I think the battery on this is running out. There you go. Yeah, okay. I'll point to you in your spacebar. So what IDC did this pyramid. I don't know. Have many of you seen this pyramid? It's been around for about 20 years. What is a way to try to understand what the availability solution sphere of technologies actually addresses. At the very bottom is a thing called AL0, or availability level 0, which means no redundancy. Just a single server, it stops, go order a new server, wait for it to be delivered, go you know, hook it up with the software on it and whatnot. Obviously in the era of cloud, we have a lot more flexibility around unprotected servers. We can go create a new service, you go to another region, build it all up. It won't take us the week to order and whatnot, so it's not as bad as it used to be, but it's still a lot of work. The next one is around reliability, and that's really where we are today in cloud, and that's just hot swappable components, but you have the same problem. You got to recover. There's no promise around data. And the next one, AL2, is really about just basically data backup and replication. Again, that's a 3-9 solution, about, you know, more than 8 hours a year, roughly. And then AL3, and this is the space that SIOS operates, is high availability, specifically traditional high availability clustering, and that's the 4-9 space. True redundancy, automatic recovery, no data loss. RPO is 0, and then there's continuous availability, which is system fault tolerance, and that's where all components are redundant, and any kind of failure is never ever seen. The largest outage is about 5 seconds. And this is the sweet spot for critical systems, because you get the most flexibility, the technology allows it, it's the best fit for most of the problems. Go. Right. So clustering in this space has been the go-to HA solution for probably 30 years at this point in time. And it's all about databases typically, because those are transactional and they have this kind of, but they've traditionally used a shared storage technology so that if one server fails, then we go from an active to a standby. So this is from the active, and we recover the system on the secondary server. That recovery is sort of the last gasp that you do when there is a failure. But it's always dependent upon that shared storage. So there was really no replication other than the storage itself being redundant. If storage itself is being redundant, this becomes a single point of failure. So a lot of the things you have to think about in constructing these things are redundancy of everything. Redundancy the storage, and redundancy the wires to the storage, redundancy in the networking capability so that you can access the new server and make sure it's, so there's a lot of things to think about in terms of constructing these. But it does give you a lot of flexibility as well. You can have multiple nodes, you can have a third site that's a DR node, you can use synchronous, you can do a lot of other capabilities with this. Can we flip it? So, but the new data center needs high availability without depending on storage, shared storage. So what we've done in the SIOS implementation, and you'll see this elsewhere as well, is provide a shared nothing architecture where the storage itself does not need to be shared. In fact, the servers are just connected by wires, and we manage the whole stack. So we can do that with 2 physical servers. We can do that in multi-site environments out of the box, and we can do that with replicated in cloud. Or to cloud. We have customers doing this. We can do it in virtual servers, and you can do it in high-performance storage where you just have NVMe RAM and you got to go fast, and we can do that in the cloud. So all these different ways of constructing it are part and parcel of what you want to be able to do with this high availability technology. In terms of the anatomy of this at the high level, how do you create a solution that covers all these different use cases and all this in the new data center, physical, cloud, and hybrid? There's really 3 levels. You have the application recovery kits, which are really powerful kits that you can extend in order to in order to understand and detect the problems that are happening at the application tier. We have recovery orchestration that helps you understand how you want to take how do you want to interpret what's happened with the problem and to decide how you're going to recover and how to orchestrate the pieces to recover. And then in the data tier, you manage the environment depending upon whether it's a physical shared storage environment or something like a cloud environment where you don't have shared storage, or a hybrid environment where you might have an on-premise system and an in-cloud system. So you can do that all with one architecture, using what we call SAN and SANless clusters. So this is really, that top tier is really about discover, recover, and continue. And the data plane is all about the redundancy. And if you think about RPO and RTO, and you just click forward, RTO is really about all the time it takes to get this stuff to all work in a failure case. And then the RPO is about the data redundancy piece. So that's how it's all defined and pulled together. And packaging this all up into a single package and making something that's very hard to do much easier to do and test and reliably recover is a lot of where we spend our effort. So if you look at us in another way to look at this pyramid, and this is how Gartner is looking at it, is the IT resilience, which is really about a very wide variety of RPOs, different recovery points with some automation. High availability is an aspect of IT resilience. Beyond replication and backup. And then HA clustering is a form of high availability which has the multi-node active standby failover technology. And then in SIOS, where we differentiate is really an out-of-the-box cluster solution that has any platform or OS application. Comprehensive coverage across a lot of different failure cases and pre-tested and reliable. And reliability, as I said, is a big deal if you're going to buy an insurance policy. The products we have are in both Windows and Linux. We have a product called Data Keeper Cluster Edition. We're focusing on SIOS Protection Suite for Linux, which is an enterprise-ready Linux for enterprise-ready Linux clusters. And what we talk about always is where we can do it. We can do it on any Linux distribution. In Windows, and we look at higher availability, higher reliability, and lowering your cost overall. And the distributions here, you see the platforms go across Amazon, Windows, Azure, Google Cloud Platform, VMware, Windows V, Hyper-V, physical platforms, OSs, SUSE, Red Hat, Windows, CentOS, and applications cover SAP, DB2, just about any database. Plus we have application recovery kits that are quite generic that you can extend to a lot of different environments. Now I'll turn it over to Michael.
Okay. I think my volume's up very up. We'll see if it works for me. Maybe it just doesn't like you. It doesn't like you. It just worked for me. So, however, okay. So a couple of use cases Jerry mentioned. We'll just briefly go over a typical cloud because the cloud is the hottest topic out there. So in AWS, we orchestrate with AWS CLIs in order to get typically the VIP flipped over between those two nodes out there. The typical implementation, which we'll get into in detail, are basically equal installed hosts, right? So SAP Stack 1, SAP Stack 1 on two separate nodes. We handle all that replication, not only at the data layer, but the redundancy of being able to get all of the application components to orchestrate in success for recovery on that other node. So that one block of SAP represents all of those things Jerry mentioned, right? It's not just the one thing. And if one thing starts before another in terms of orchestration, the application will fail to start, right? I can't start the app without the data being ready, mounted, etc., right? The architecture in SAP specifically goes, wildly in many, many directions, right? We've seen customers do a lot of different things. There is no sort of generic, this is my SAP build, right? That's why I can't just simply deploy an AMI that's on some cloud vendor site and say, hey, look, I just deployed SAP, it's all set. It's usually a lot of planning, a lot of architectural review and configuration. But the flexibility of SIOS's protection suite enables you to wrap that around whatever that customer's best practice, business requirement, configuration is to make it that simple, right? So we're off in AWS, same use case in Azure, right? The cloud is the cloud. We have that integration point in Azure to talk to the Azure CLI, to talk to the AWS CLI, and soon enough, this will become a common topic out there. Google is not sleeping out there, right? The Google Cloud Platform is becoming a topic of consideration, at least, in a lot of our conversations. So you notice also we have the ability to not just take care of two redundancy zones, but we can have a third out of region for a DR copy. Now that might not be synchronized because that synchronous wait time will decrease performance, but we can set that third copy to async, and that's a very unique feature because we understand how to, in a failover situation, if we had to go to that third node, we have the ability to wrap around all those networking considerations because typically you're not in the same CIDR when you're out of region, right? It just, it presents that challenge. But the flexibility of the product, we could literally have this thing insert your start, stop, restart, and health check script that is even your homegrown application, and it will do what you tell it to, right? That's the extreme case of flexibility. Now, for the SAP kits, all of that logic, we've spent many hundreds of hours into that recovery kit intelligence. And the recovery kit intelligence enables you to simply use the product from a wizard level. Add my ASCS, and we know in that ASCS profile information, I am looking for all the things that are in this specific build to get the ASCS up. I know where the data points are, I know where the mount points are. If there's NFS requirements in the SAP profile, we discover all that under the covers. And the reason why is because we invested all that time into the recovery kits intelligence. So that's really the secret sauce of these recovery kits in conjunction with the orchestration ability of the product. We're going to get deeper into that. So if any money shot of you needed to explain, what's that SIOS protection suite architecture look like? These are the three majors. And based on Jerry's conversation at a higher level of there are a lot of pieces you need to consider, and all of those components need to be touched and wrapped around, this would be the slide. So the SIOS protection suite for Linux incorporates at the lowest level the data keeper function. The data keeper is all about the data replication. In the two HA nodes that are partners for the sort of tier 1 failover, and the data keeper replication will be in synchronous mode, so every single block written will be written to both before an ACK gets back, right? If, in fact, you have that third copy, we'll set that to asynchronous mode, so it doesn't bother the performance of the tier 1 application we're dealing with. There is also, in the data keeper layer, a thing called a bitmap file, because these things need to be maintained. They need to be touched. You have to reboot hosts on patches or maintenance, or maybe something bad happens. Do I have to re-sync 10 terabytes of my data? That would take a long time in the cloud, right? So we have this bitmap file that will keep track of how many blocks we owe that copy. So in the event you need to do some maintenance that does require a reboot, you could do it with confidence, because once that machine's online, our software is saying, are you back yet? I know I owe you some blocks. And it will, of course, propagate up to the GUI and alert saying your synchronous replication's out of sync right now. And that's understandable because you're doing some maintenance event, right? Once that's back online, it'll take a look at that bitmap file, which is just a bunch of ones and zeros in relation to the block mapping of the device involved. But it would incrementally update that and carry on, get into full sync, and recover your ability to fail over in the event something bad happens, right? At that layer, the data keeper is probably the most important component, right? Because the data is gold. Now, going up the stack a little bit, how do we talk to all of these resources? How do we know what's in SAP? How do we know what's in Oracle? How do we know what's in the configuration for NFS, in the operating system resources, the IP configurations? There are so many pieces in the application stack, it becomes very, very difficult. And I know there were other sessions that talk about open source components, Chorus Sync, all of those things that you're going into conf files, editing things to protect that one piece. But what about the orchestration of all of the pieces together? So that's where the LifeKeeper product comes in. This is the umbrella that understands how they all relate to each other. It'll maintain all the component relationships to the application stack, not only on the primary node, but where is this thing protected? Oh, there's another node out there, and that is my partner of a failover event. And the LifeKeeper is aware of that configuration. And the LifeKeeper layer also provides the GUI service if you wanted to use a GUI. In a lot of places, we have scripts that talk to our CLI. There's an extensive CLI that basically, when you need to exhaust a host for maintenance, you just run a switchover command, bash shell, so that I'm not sitting there at a command line making human errors, doing bad things, right? So most customers would run a CLI in LifeKeeper to say, exhaust host A, because I need to maintain it. And it will do a gracious switchover to the other node to make node A available for you to do whatever you needed to. So these three things together, data keeper at the data layer, application recovery kits, I think we killed this story. Those arcs cover everything, all the other pieces of that application stack, because every single piece is required for that application to be looked at as healthy, right? And in order for it to start up right, these things have to be orchestrated by LifeKeeper to start in the proper sequence. So that's the money shot for the intro to the architecture. and that's the protection suite for Linux. It's not just DataKeeper. Some of you folks may have history or colleagues that say, oh yeah, I used SIOS before, but they used it on Windows. And typically Windows, we present the DataKeeper layer to Windows failover clustering, and we walk away. That's pretty simple and straightforward. But there is no Windows failover clustering in Linux. There is no staple go-to management suite for HA in Linux. And I'm not talking just SLES, but what about Red Hat? What about CentOS? You know, what about OREL or other OSs, right? There is no, you know, HA extension from SLES on a RHEL or Oracle Linux, right? Because it's not there. It's not the same OS. It's not the same company. We can provide that consistency across all of those flavors because we basically present our quote unquote, you know, Windows failover clustering staple as Lifekeeper for Linux. So now you have a standard without needing to learn 7 different ways to do the same thing, right? It's a go-to. So getting a little bit deeper in the data replication, how's this magic happen? You have 2 nodes. You don't have shared storage. How are you maintaining the replication? So we inject a network block device driver into the SCSI stack, and injecting that network block device driver enables us to use the existing LAN between the 2 nodes to send that replication across the LAN at the block layer. So we don't have to traverse all the file system logic because that will cost time, right? So we're at the block layer, the most efficient layer, and that replication source and target is the relationship of a simple 2-node solution. Now, if I had that DR node out here, I'd have another target, right? And that one would be in async mode because we don't want that to bother the performance of the 2 primary HA nodes. So in the event of a failover, we just swap these profiles. Have this be the source, have that be the target in the event of a failover. So if this node did go down, this would become the source, and we don't have to worry about, well, wait a minute, we have to reapply logs. We don't play at that layer for the replication of the data itself. We're at the block layer. The very last write is there because we're in synchronous mode for the replication. Now, once that node comes online, that becomes the target. Our software is constantly checking. Are you back yet? I owe you blocks. Remember the bitmap mentioned in the prior slides. So once that comes back online, it will sync automatically hands-free once the resource becomes available again. Now we'll get a little deeper. Whoops, I'm flying. So the recovery kits, this is what really wraps around the whole application stack. And this is just a subset sample of, you know, at the base there is storage of something, right? We already killed the DataKeeper topic. Next up, the database relies and uses that storage for its user data, etc. But that database is serving something. Some type of application is using that DB, so now we're at the application tier. But in order for the application to run, you know, there's a lot of services at the host level. Maybe there are unique things that the application presents, not just one process, but multiple processes. And keep in mind, everything must start in the exact proper sequence for a failover to recover and start successfully. Right? And that's where it becomes really difficult for the open source type of solutions out there for HA to really get a solid, reliable result from deploying an HA solution. And this is where we shine. That Lifekeeper logic, the orchestration, the intelligence, and the recovery kits. I don't have to be an expert in Oracle. I just go through a wizard, you know, with the proper credentials, of course, but I'm prompted with a wizard. Which database? Drop down, select this instance. Okay, you're replicating this to that. The Oracle kit understands which data it needs. So first I'm going to present the storage tier to our protection first. And then when I deploy the Oracle, it's going to know to check for that because it has that built-in intelligence, right? So it sort of guides you along, avoids you from doing something bad in you know, the misconception of I'm protected. That intelligence doesn't exist in sort of the open source, put it together yourself type of solutions. At what level is this intelligence enabled? Well, we're certified in NetWeaver and HANA with SAP. Huge amounts of effort. A lot of partners assisted us in these efforts, just sitting in this room from AWS, et cetera, right? But enormous amounts of effort to get that certification badge, because they look at it as, we know SAP and you better do it to our level of expectation. So this certification is huge. It's not just the partner level, but of course we are an SAP partner because it's important to have, you know, the tech layer in the stack, and also be a partner and keep hand in hand in step with their releases, with their next gen features, etc. Okay, a lot of things on this slide. I broke the slide rule of 7 bullets, but you know, the point here is we are aware, this is an example of an SAP recovery kit, right? We're aware of all these components. All these components might not apply to every single build of SAP. As we mentioned before, SAP can be wildly unique per customer. But the point here is we're aware of that whole list of components for SAP because of the intelligence of that recovery kit, in addition to the back-end sort of staple resources like NFS mounts, IP management, and of course the data replication, right? That's not unique to SAP, but this list is, you know, represents the true intelligence of the application recovery kits. And that's just the SAP sample. Remember, we're not just an SAP solution, right? We can protect many, many tier 1 applications. So our integration with SAP HANA database, because that's in memory, now what do? We're not a memory protection solution, right? That data keeper works at volumes presented to a host. But HANA has the HSR, right? HANA System Replication. The problem with HANA System Replication, where's its automation? Where's its orchestration? If a failure occurs, what has to happen? Jim, HANA failed over. Can you log in, take a look, get the synchronization back to the original node once it recovers, and then switch it back to the original node? So our wrapper around this takes care of that, where your help desk can use our GUI to say, okay, that's up. Let me look at step 2. Oh, the replication already is aware to load the memory back to the original node. That's done with the product. And then finally, all right, I need approval just to get that HANA instance back to the original node as the primary, right? And the replication behavior in the HSR layer will change its profile, right? You can't do this without a really powerful orchestration tool. And that's where we come in, even at the HANA level. It's a very unique use case though, right? Because we're not talking about data replication with the volumes, et cetera. So getting back to SAP in the cloud, it's usually built in tiers, right? So we can protect the database layer with all of those elements that makes a database run. And this is very common. We see this all the time, where it's a database tier set of servers and then an application tier set of servers. But whatever these requirements are, we wrap around that use case. And remember, we could have that not only the 2 in-region availability zones protected, but we could have a 3rd out-of-region copy also with this solution. Getting to that client level, right? It's not just getting the data up, right? All of those pieces have to be updated, and then, wait a minute, I'm in Azure, I'm in AWS, I'm in Google. How do I manage the IP? How do I get that to flip over? How do I get my client access back up? The application's back up, but our integration with those other tiers wherever we're living enables us to go all the way up so that client gets the actual connection recovered, right? Without an admin intervention. So the 2 a.m. phone call, it's not going to happen. A great use case with one of our big fruit manufacturers, we migrated 21 SAP stacks into AWS. And they sent us a note a month after implementation. And it started out with, your product failed over and we didn't know why. So at first we were sweating, but the story went on where they said we had no help desk calls, we had no user complaints, we didn't know what went on until we started root causing it. It turned out that they had this Trex application in their SAP stack that did very bad things and ran away with CPU at 99%. And our health checks saw that happening and said, this thing's gonna go down. It's failed the check 3 times go. And so in turn, we triggered the failover in an emergency. And it recovered before anybody even knew what happened. So when we got to the end of that last paragraph, we're like, all right, that's excellent, right? I mean, that's proof in the pudding in my book. Anyway, moving along. Here's our third site, out of region, second region DR site. In that orchestration, remember, we have that ability to really talk to the whole stack. It's not just inside that operating system or just inside that application stack uniquely. We're aware of the global layer also. So getting back to sort of relating to Jerry's marketecture and the Gardner Group reference, what is IT resilience, where do we sit in the pyramid? SIOS is RPO 0, all right? So if a customer is like, well, no, I already have, I have Azure Site Recovery, I have some DR solution, I have something, I'm replicating things, and yeah, it's replicating that data, the data is protected, but that's plus something in time, right? So we are living in the very last right in the application. So that left yellow stack is not only for the data layer, but we are aware of the entire application stack at the very point of time of T plus 0. And that's a very critical path for HA, right? We're not displacing any of these other requirements. You're still probably going to need a DR copy, maybe snapshot solutions. But once that snapshot's done, the data's aged already, right? So that's their job, and that's a great point in time for malware attacks or something. We need to roll back the calendar. But backup recovery, archive, long-term retention, we don't displace that, and nor do we conflict with that, because we're RPO 0. That's where we live. So busy slide, but that's the whole point of it. So coming up for air, what does this thing look like? What if I had, picture in your mind, I have 2 VMs. I have equal installs of my critical tier 1 application. You can say SAP if you want to, but it doesn't have to be. It can be an Oracle, it can be a PostgreSQL, it can be whatever. We are aware of all the components, and now you guys are experts because you know the application recovery kits wrap around all of these with intelligence, enabling the wizard-driven implementation and operation. And then the data keeper, we killed that topic. You guys are SIOS experts. We should get badges like I'm a SIOS expert, right? So up on top of that, Lifekeeper is the umbrella of the orchestration. He is the conductor of the world of this HA solution. And resulting in that as a business need is that application level awareness in high availability, right? So all of this ties that whole story together. An example getting into, hey, let's position this. We want to move in this direction. We're going to the cloud. What's my topology going to look like? Okay, well, we have MaxDB. We're going to deploy the 2 sets, a set of MaxDB. We're going to make that HA pair protect each other. You see the blue? How does that exist in both nodes? We have the ability to cross-protect unique instances. So in this case, I might have instance 1 being protected on the bottom host, but that's being replicated to the top node. Maybe instance 2 is normally running on the top host and being protected on the bottom. So that's why we call it active-active, but it's not active-active to the same instance. They're 2 separate unique instances. And then further up the stack, typically we see the SAP applications being separated from that backend database pair. And again, we have the intelligence to be able to separate all of those SAP components to not necessarily have to be all or nothing or primary and standby in every case. It is the most common case, but we have that orchestration ability to know who is running where, what's it supposed to perform like. The cases of ERS behavior for NQ replication, we're aware of when ASCS moves, we're going to either control ERS to move, or SAP does it by design. It knows to keep ERS away from the ASCS service, etc. And then further up the stack, whether I'm in Amazon, Azure, GCP, IBM Cloud, I don't care, we can integrate with that to finish and get that icing on the cake. So the whole result here is keeping that client access active. Coming up for air, finally, we get to see a GUI. So this is a sample, but now you folks understand these layers, right? So at this base layer of Oracle, that's the data layer. If I expanded that, and the tree is not expanded for that, you would see the data replication of the block device. And that mount point is Oracle. That's what's represented at this layer here, right? That's the mount point. Now that the data is mounted in preparation for Oracle, what's the next requirement? Going up the stack. I need an IP. I can't start a TNS listener if it doesn't have an IP. So we present that IP as a deep dependency child. Once that is there, now my listener is allowed to start because the resources are there. And finally, after the listener starts up, I can bring up the instance of P01 on the Oracle layer. But that's serving something, right? So in this case, it's an all-in-one build for SAP. The database is, in fact, the SAP host. So once Oracle is done, ASCS can start because all of its children are up and healthy. All of this orchestration, you're not right-clicking each thing and saying, start this one first, start this one second. That's all built in to the orchestration of Lifekeeper in relation to the intelligence of the recovery kits, right? This is hands-free. I just go up to the top with a message server and I say, bring it in service here because I'm doing maintenance on Prod 01. And it knows what to do. It'll gracefully shut these resources down, and it'll gracefully bring them back up in the proper order and success the first time without you needing to tiptoe or call Jody or call Jim to say, what should I start next, right? Because the solution's already implemented, the intelligence is in the product. I mean, this is a real software solution for HA. This is not, let me wrap all these open source components together and give you a GUI, but then in order to get it to work, you have to spend months trying to sort of get that intelligence and orchestration functional based on whatever you're using it for, right? This is a prepackaged solution. So the simple user interface, this monitors and administers the clusters. All of these statuses would propagate to the GUI, but also we have SNMP and SMTP integration for alerts and help desk notifications, etc. The CLI is very extensible. I can run the CLI to gather data about my HA statuses and the configurations, or I can use the CLI to do active administrative commands. And then the dependencies and relationships in the hierarchy, that is all about enabling that orchestration and the hands-free behavior in either a switchover for maintenance or an emergency failover situation. And then, as a summary, application awareness. That's where the critical story lives for our HA solution, right? It's simple to set up and manage because those recovery kits have so much time invested. I can do it at a wizard level, essentially. The flexible storage options doesn't really apply much today because we're not on-prem so much anymore, but just FYI, I don't care what storage is presented, we can address that because we're aware of those OS layers and have a long history there. So all together, it makes it a cost-effective and fast-to-deploy solution using your existing configurations. There's no requirement to say, oh, you need to have this specific physical hardware in the back end or none of that. It's OS based. And keeping in mind it's OS based, I don't care where the OS is, right? I can run it on-prem, in the cloud, whose cloud, I don't know, whatever cloud you want to use, right? So that's the summary for Linux, and I believe that's the end. So questions, answers, you guys should answer me, right? Yes?
How does your replication technology differ from DRDB, or how does it compare with DRDB?
For DRDB? So DRDB does a job. It does replication of data. That'd be cool if you were only serving a file share for somebody, right? What about, what's the data being used for? What's the orchestration requirements to have that data get replicated, plus mounted, plus all those application components, plus that whole stack we talked about, right? So DRDB does a job, but that's just one little piece of the pie, right? And we need to, as Jerry's slides, there's a big requirement here. I need application-aware HA, right? So DRDB and the open source components all together, the core sync, pacemaker, all of those things do stuff. But it's not a packaged solution that has 20 years behind it, built-in intelligence to integrate into tier 1 applications with those results of simplicity.
My question was slightly different. I wanted to understand how does it differ in terms of technology, in terms of what it does. I understand the other pieces that need integration to provide a complete high availability cluster. I was just talking in terms of the data replication piece of it.
Right. Edmund, compared to DRDB, what's your short and sweet? Oh, Paul.
Yeah.
Hello.
And you mentioned that you can use the CLI to administer the cluster. Can you do the complete setup of the cluster just with?
You can add the primary node via CLI to add the resources via CLI to deploy it. Like we're working with some Microsoft Fast Track folks in the back end in Microsoft, and they use Terraform to deploy the solution, right? Terraform scripts. So you could do it on the primary node, but to extend it, the GUI has to be used today. You could try to reverse engineer it. You'd end up with pages and pages of scripts to attempt to do that. Okay.
I used to work in MSIT. Mm-hmm. So the reason I ask this question is security has been tightening up the rules, and graphical interfaces are one thing which they're kind of frowning upon.
Yes.
So that's where the question is coming.
Yeah, it is known as a target for us, definitely. Yes, yep. And I mean, we can discuss between Jerry and Jonathan's product manager and their VP of product management is in back of you also. So yeah, it's known, you know, it's obviously the automation is important, but the hands-free deployment that's money in the pocket, right, also, in addition to the security concern.
So if there are multiple clusters running your solution, is there a single interface where you can monitor all of them? Or?
You just add hosts, and you could add it, even though they're not related directly or protecting each other in any way. You could just have that GUI have a set. You'd be scrolling a lot if you added all 80, you know, if you had that many hosts, but it's possible.
Trade-off between scrolling and then having to open up multiple different interfaces.
Yeah.
That's still easier.
Yeah. I mean, typically people just script what they want to know or do. In those scripts, you know, even if you click on the wrong thing, bad things can happen, right? So usually people have that level of protection, and they just automate with scripts and format their output with, you know, some.
And do you have an API interface that people can just call into and pull out information?
Yes, yes. Is that part of the CLI? You can do that, right? There are some things that are late breaking, but I'm not sure I'm permitted to share the information publicly. But it's definitely, all of these things are important parts that are either close to becoming GA or you know, aware and at the top of the list. Jerry, any questions? All right.
Appreciate your time. Hope we've given you some information that's useful.